In this illustration, we intend to teach you how to generate the tool path in the incremental sheet forming process using the abaqus and Matlab software. Actually, we are going to define the moving of the tool path using Matlab software. The tool moves in a spiral path that causes the sheet to be formed gradually, and you can observe this spiral path in this picture. This training includes two sections, and in the first section the incremental sheet forming will be done for the 120-degree cone, and in the second section the incremental sheet forming will be accomplished for the 80-degree cone. The sheet is made of aluminium with a length and width of 320 mm and a thickness of 2 mm. I will enter the length of this line as 95 mm. Enter this distance as 50 mm, and enter the distance between this point and the axis of rotation as 145 mm, and finally click on Done. I'll click on Translate Instance, select Punch, Done. Enter the start of the translation vector as 0, 0, 0, and the end of that as 160, 0, 0, and OK. In this manner. Click on Create step. Here select Dynamic Explicit and continue. Time period is equal to 800 seconds. Here I'll tick on Use Scaling Definitions below option. Click on Create. I will click on Create Interaction again. Select Surface to Surface, Contact, Continue. Select Punch, Done. Select the exterior surfaces that are in brown color. Click on Surface. Select the sheet, Done, and select the top surface of the sheet that is in brown and OK. Then I will click on Assign Element Type, select the sheet, Done. Here I will put the element family on Explicit and OK. Here we intend to do the incremental sheet forming for the 120-degree cone. As you observe in this picture, the angle between the slanting line and the vertical line is 60 degrees. In this example, the tool moves in a conical path, and so we use Matlab software in order to define the path through which the tool moves. Well, first I'll open Matlab software. We should do the following steps in order to define the path through which the tool should move. Step 1. In the step 1, you should define time period using Matlab software. In this example, time period is equal to 800 seconds, and you can observe the instruction of writing down codes in this picture. I will enter Matlab software. Here I will use line space instruction. Step 2. In the step 2, you should export the data from Matlab software to the Excel software, the instruction of which has been written down here. Well, here I'll open the Excel file. As you see, the data related to the time period has been saved up in here. Actually, the information has been exported from Matlab to Excel software. Well, I'll select my intended information, copy that. Here I'll right click and select transpose option. As you observe here, time period changes ranging from 0 to 800 seconds. Step 3. In step 3, you should determine the line slope using Matlab software. As you observe in this picture, the line slope is equal to 130 divided by 75. Here you can observe the information related to Z coordinates. I will copy the data. Here I will right click and select the transpose option. I'll right click here and select sort smallest to largest option. Then select this column. I will select these two columns and select this diagram from Insert menu. Then click on Create Amplitude. Here select Tabular and continue. I will select these two columns, copy, and paste them here, and OK, and OK. Continue. Here I select double analysis only in the precision edge, OK, and click on Submit. The analysis was done successfully, so I will click on Result. as you observe the tool moves in a spiral path. Here you can observe the thickness of the sheet, and as it is observed, the critical thickness or the minimum of thickness is equal to 1.7 millimeter. Actually, the final shape is a 120-degree cone, which can be observed here. The height of this cone is 40 millimeter. In the second part of our training, we intend to simulate the incremental sheet forming for the 80-degree cone. We use Matlab software in order to define moving of the tool path. We should do the following steps so we can define moving of the tool path. Step 1. In the step 1, you should define time period using Matlab software. Here you can observe the related instruction. Step 2. In the step 2, you should export the data from Matlab software to the Excel software, the instruction of which is quite clear here. Here you can observe the manner the tool moves in a circular path. Here you can observe the manner the tool moves in the XY plane. Here you can observe the path through which the tool moves in a three-dimensional space that is similar to a truncated cone. I click on Create again, Continue. Select these two columns, copy, paste them here, and OK. Here I will click on Boundary Conditions Manager. Here click on Edit. The analysis was done. I click on Result. From here, select the 120-degree cone and 80-degree cone from here. Then I'll select Link Viewports from Viewport menu in this manner. As you observe here, you can compare easily the outcomes of the incremental sheet forming process of the 120-degree cone and of the 80-degree cone together. The left picture is related to the 120-degree cone and the right one is for the 80-degree cone.